Hi, I am Varun Joshi, and welcome to day 40 of our Certified Kubernetes Administrator 2025 course. Today, we are diving into one of the most powerful abstractions in Kubernetes operators. If you ever wished Kubernetes could manage complex applications just like it handles pods and services, operators are your answer. In this lecture, at the very last, we'll also be doing a demo of Kubernetes operator called Kube-Green, which can scale down your workloads during non-business hours or at the time that you specify. Before I start this one, it will be nice if you have watched day 39 of this course, because it is there where we have covered custom resources, custom resource definitions, and also talked a lot about custom controllers. But here is a quick recap of day 39. Let me zoom in a little. So we discussed that the resources in Kubernetes can be of two types. There are default resources. If you have a vanilla Kubernetes cluster and you run kubectl API resources, the resource list that you see, all of those resources are default resources because they come with the installation of Kubernetes itself. But as we also understood, Kubernetes is an extensible system. Hence, you can also create your custom resources. What we then learned was, if you want to create custom resources, what you have to create is something called custom resource definition. Custom resource definition is like a template where you define the schema of your custom resource. And when you create your custom resource, you reference the schema that you have defined in CRD, and then you create a custom resource. If your custom resource does not adhere to the schema that you have defined in CRD, then the creation of that custom resource will error out. Then we learned you can have a custom controller that manages your custom resources. If, for example, whatever you have deployed is prone to a drift implies a state wherein the desired state does not match the current state, then custom controller can take action and adjust the current state to match the desired state. And what your controller will do is, controller runs something called a control loop, and that loop observes the desired state, compares that state with the current state, take action to reconcile if the desired state is not matching the current state. And then in our demo section, we created a CRD, and out of that CRD, we created a custom resource. The custom resource that we created dealt with backup. In our custom resource, we specified a schedule, the retention days, and the target PVC. We also understood that just creating a CRD and a CR will not do anything until and unless we have a controller that is constantly watching this CR, and based on what we have defined in this CR, it is the custom controller which holds the logic and performs the actual tasks that are to be performed for this CR to function properly. Now, with this quick recap, let's go back to day 40, which is Kubernetes operator. Now, let's just read this line. Deploying applications on Kubernetes is relatively straightforward, and we have been doing this since the inception of this course. We have been creating deployments, services, and so on, and we have accessed our application from within the cluster and also from outside the cluster. We have deployed our applications using manifests, or there are other options like Helm charts or Kustomize. And we'll see what Helm chart and Kustomize are in the later part of this course. But for now, understand when it comes to application deployment, you can either single-handedly apply all the manifests that you hold that are part of your application, or you can use Helm or Kustomize, which can be thought of as a one-click option to implement your entire application. Then what we are saying is, but stateful and complex applications such as databases like PostgreSQL, Cassandra, any relational or non-relational database, or message brokers like Kafka or RabbitMQ, essentially your middleware, or monitoring tools like Prometheus, Thanos, New Relic, and so on, require far more than just installation. So before I dissect this definition along with you, let's understand what are stateless applications and what are stateful applications. Let's clear one thing. When I talk about stateless application, an application could be consisting of multiple components. An application could have a web tier, an application tier, and it can have a data tier. And these tiers can either have microservices, or they can just have the entire logic for that specific tier. Web tier could just be holding the entire web tier logic, or web tier could be split into multiple microservices, like one microservice for the mobile user, another microservice for, let's say, laptop or computer users. Then similarly, application tier could be a single code base, or it could be split into multiple microservices. And if you have any confusions about what are the application design patterns that you would most definitely see in production implementations, then I will recommend you to go and watch day 11, because in day 11 we understood what is a 3-tier design, what is middleware, what are the famous programming languages that you would often see as a DevOps engineer, and finally we concluded this lecture by understanding how an e-commerce website would function, which uses the modern microservices architecture. So let's go back to day 40 now. And this is what we have. We have a web tier, we have an application tier, and then there is a data tier. We understand that web tier is the one with which user interacts. Then there is application tier, which is also called backend, and application tier is the one that holds the application logic, that holds the business logic. If someone is clicking on wish list, what will happen is decided by application tier. If someone clicks on the cart, what will happen is decided by the application tier. What will happen if someone clicks on a product is decided by application tier, and so on. Then we understand there is a data tier. Data tier is the one that holds the storage. It stores everything. And if application tier wants to retrieve something, it can retrieve from the data tier. And later we'll see how a caching system comes into picture and how that works. Now let's understand what will happen when a user tries to access the website. And by answering this, by working with this flow, we'll also answer what are stateless applications and what are stateful applications. And understand, like I said before, an application can have multiple components. Like here, application has a web tier, an application tier, and a data tier. And those tiers, some tiers could be stateless and some tiers could be stateful. So stateless application as a whole is an application or an application component that does not store any data within itself. So what I mean by that is, if my web tier is stateless, that implies my web tier is not storing any data. It is just storing the front end logic. That's it. If my application tier is stateless, then my application tier is just holding the application logic. It is not storing any information, it is not caching any data, it is just plain code. That's it. When I talk about data tier is typically the one that is stateful, because it is the data tier that is holding your data. Now, since there is a difference between stateless and stateful workloads, how you deploy them onto Kubernetes is also different. We'll have an entire lecture dedicated to stateful sets, which is something that you would use when you are deploying database onto Kubernetes. But in this lecture, I wanted to explain you enough so that you can clearly correlate stateless and stateful and how these things fit into the Kubernetes operator ecosystem. So let's say Varun accesses a website, Varun logs in, Varun chooses this is my preferred language and this is the currency I want to use. If this pod dies, which was catering to Varun's request, then another pod will cater Varun's request. But this pod does not have the information that was available with pod 1, because it is the pod 1 which knew my language, which knew my currency, and so on. Since this pod has now died, I'll have to be served by pod 2, and pod 2 does not have my information. So this is the problem with stateful apps. If my web tier was stateful and storing my information, then if a pod was down which was catering me, then another pod that will cater me will not know anything about the session, because the session information was only available with pod 1. Since pod 1 is down, everything will have to be readjusted by Varun. Varun as a user will again have to tell his preferred language, tell his preferred currency, and so on. Hence, the user experience is not something that Varun expects from a good application. So in here, we brought in something called Amazon Elasticache. Now, this could be any caching solution or any solution that will store user information. Now, let's revisit this when there is a caching solution in place. And this caching solution will be holding Varun's session information. Now, this user we know is Varun. Varun now tries to connect to the web tier. Even if pod 1 now dies, Varun's session information will be safe, because that is being now stored into an Elasticache system. The session is stored somewhere else. When pod 2 takes over, pod 2 will directly refer to the session information that was previously available. This is a true stateless web tier which is not storing any information. Now, what this session information could be, it could be which site referred Varun to this site, it could be the active promotions that are ongoing, it could be preferred language, currency, theme, dark mode, light mode, location. The session information is essentially the user preferences. Hence, it is always good to have stateless components wherever possible. Outsource everything. Your tiers, your microservices should only hold application logic. And here I have again showed a caching tier. Application tier is also accessing Elasticache. Now, the reason for that is modern applications do not rely on databases for everything. Anything that was recently accessed by some user is cached in a Elasticache instance. I'm talking about Amazon here. If you are on Azure or GKE, it could be your cloud native caching solution, or you could be using a third party caching solution as well. In here, application tier is using this Elasticache to store any recent information, because this cache is extremely fast and my application tier only reaches to the data tier when the data is not available in the caching tier. Now let's scroll down and understand what it takes to deploy a stateful workload like a database onto Kubernetes. Firstly, I want you to understand one thing very clearly. Databases cannot be implemented using Kubernetes deployments because essentially in deployment, every pod is same, and that is why they are called replica. And if my master, for let's say my database, is down, I know for a fact that my mirror 1 and mirror 2 are not exact replicas, they are just mirrors of my master, and we'll learn more about this in our stateful set lecture. But for now, understand, if I am deploying a database onto Kubernetes, I must first design a master, then I should be deciding how the master will be replicating to mirror 1, and then from mirror 1 I can replicate to mirror 2. This is something that I will decide. What tooling will be used to mirror 1 to mirror 2? What tooling will be used to mirror master to mirror 1? What will be the pod names? Because understand, if my pod is connecting to my database pod, then the database's pod's identity should not change, because here you cannot use your native Kubernetes services that we have been using thus far, because that service, that cluster IP service, was distributing the load. Here I do not want to distribute the load, hence I want consistent identities. Additionally, I do not want these pods to come up simultaneously, because mirror 2 will hold no use to me if mirror 1 and master are not available. I want these pods to start in sequence. I first want master to come up, then mirror 1, and then mirror 2. Hence, there is a lot of work when we talk about deploying a database onto Kubernetes. Now, what that work is, let's see now. DevOps engineer and a DBA both will be playing a role. DevOps engineer will be provisioning volumes, configuring stateful sets, setting up headless service. We'll see what these things are in our stateful set lecture, but for now just stay with me. Then you will be bootstrapping the replication logic. We'll be adding liveness, readiness, or init containers as per requirement. We'll be managing secrets, config maps, RBAC. We'll be scheduling backups as well, so we'll have to configure cron jobs. We'll have to monitor the database. Lastly, we'll have to implement custom failover logic. So these responsibilities are largely onto DevOps engineers. Having said that, when you also have a DBA involved, then there is a crossover that you would see. The responsibilities that are with DBA are designing replication topology, configure replication parameters, manage failover and promotion, define backup restore strategy, tune performance parameters, and ensure replication consistency. Now, these are a lot of tasks. Even if you automate a certain section of these tasks, you will still have to do a lot of work. How can we ensure there will be no human errors? How can we ensure when these databases are deployed, they continue to function as we expect? We have to monitor these things continuously. And guys, in here comes in Kubernetes operator. Previously, like you saw in this current architecture, there were two human operators that were doing the tasks from configuration to operations to monitoring and so on. And here I have just shown two. There could be multiple engineers working in streamlining your stateful applications or your complex applications when deployed onto Kubernetes. Here comes Kubernetes operator. Previously, these were human operators. Now, whatever tasks were performed by human operators are given to the Kubernetes operator. What is a Kubernetes operator? It is a design pattern used to manage complex, often stateful or operationally heavy application by codifying domain specific knowledge into a custom controller that runs inside the Kubernetes cluster. Like I said before, if you understood CRDs, CR, and custom controllers, then Kubernetes operator is a cakewalk for you, because Kubernetes operator is just a logical construct. There are components within the Kubernetes operator that ensure that the operator is doing the task it is supposed to do. Here are the core components of an operator. We understand what CRDs are. They extend Kubernetes API by introducing new resource types. Essentially, what are CRDs? Templates for custom resources. Then what are custom resources? Custom resources are instances of CRDs created by the user to express intent. So if I in lecture 39 created a backup policy using the custom resource, then my intent is to schedule the backup at this time, retain the backup for these many days, and the PVC is this one. So here we are using CRs to express our intent. Example, run backups every night or deploy a 3-node DB cluster. So whatever we did manually here, end to end, can be streamlined by just one click. And if I go to my browser, we took an example of MySQL or any database for PostgreSQL. If I go to operatorhub.io, this is the place where you can browse all your popular operators. And if I search for MySQL here, you will see that there is an operator for MySQL. If I search for Postgre, you will see there is an operator for Postgres. Similarly, there are operators for any complex application, and I'll show that to you as we progress with this lecture. But for now, understand that what are the core components of an operator. We saw CRDs, CRs, then there is custom controller. And what are custom controllers? Custom controllers are the one that is performing the actual logic for your application. If you are dealing with databases, for example, controller will have the logic on how the replication would work, how many mirrors will be there, how many masters will be there. They will be defining the backup and restore strategies, and so on. Essentially, an operator is taking care of end-to-end life cycle of your application. So here are the important functionalities: coordinated scaling and upgrades, backup and restore orchestration, health checks, self-healing, failover automation, observability integrations, and so on. So whatever you can think of, an operator can do, as long as you can write the logic for it. That brings me to a point that an operator, there are operators that are readily available, and there are operators that you can write for your specific use case, and we'll zoom into that in a little while. And in the core components of an operator, I have also shown Kubernetes resources. These are the default resources, and here are the custom resources. How are default resources a core component of an operator? I want you to understand that whenever you are deploying, let's say, an operator, it could also have the default resources. For example, if I am creating an operator for my application could be using deployments under the hood, and deployments are part of default Kubernetes resource. So do not limit your imagination. Whenever you are thinking of an operator, think of operator like an automation engine. It will automate end to end for your application. Now that could involve custom resources. It can also involve default resources. And then we already know that CRDs will always be there if you are creating custom resources, because in the CRDs is where you define the templates for your custom resources. Now let's scroll down and see what else I have in store for you. Do not limit your imagination with operators. When most people first hear of operators, they think of them only in the context of databases or stateful apps. But the reality is, operators are a general purpose automation pattern. They can be built for almost anything. So think of it like this. Databases we have already discussed. When I talk about Prometheus has so many moving parts. I cannot expect my DevOps engineers to manually deploying everything that is required for Prometheus. That is first time consuming, and second, it is error prone. So I want a system via which I can deploy Prometheus with just one click. And the answer to that is the Prometheus operator. So if I go to operatorhub.io and I search for Prometheus, you see that there is an operator for Prometheus as well. So if you want to deploy Prometheus onto your Kubernetes cluster, then you do not have to do everything from the very scratch. You can just deploy it with one click using Prometheus operator, and everything that Prometheus needs to run will be available within the Prometheus operator, because once you deploy that operator, it will automatically create CRDs for you, custom controller for you, and any of the built-in resources that are required by Prometheus to run onto your Kubernetes cluster. And we already understood that whenever any internal or external tools want to communicate with my Kubernetes cluster, they would be using service tokens. So by default, one thing should come to your mind, that whenever a tool wants to interact with the Kubernetes cluster, a default resource called service account will pretty much always be created. So broaden your horizon and think like that. So now, security tooling, certificate managers for TLS, Kyverno. So if I go to this site, Kyverno has their own operator. So if you want to use Kyverno, you just deploy this operator and it will deploy everything that is required by Kyverno, including the custom controller. And similarly, networking components, CI/CD platforms, they all have an operator. If an application is bundled into something, then that something is typically called operator. So if I type Argo CD here, you will see that there is an operator for Argo CD too. You can build custom operators for internal applications, SaaS integrations, or company specific logic. And we have already discussed this part. If any of the available operators do not suffice your requirement, then you can create your own operator. Now, I know someone is thinking, Varun, when it comes to deploying this application, I can use Helm chart to do that. And you are right, you can use Helm charts and Kustomize to do that. But Varun, then why would I use operators? I can just use Helm or Kustomize to deploy my Prometheus or any of the tooling that you mentioned here. What additional are operators bringing into the table? And that's something, my friends, is real time monitoring. If you deploy something via Helm or Kustomize, it is just deployed. No one is monitoring it. No one is ensuring that the desired state matches the current state. no one is doing that. That is where operators come into picture. Operators will constantly monitor that the desired state matches the current state. If someone comes and deletes a service, then operator will ensure that that service is recreated. Firstly, no one should walk into your cluster and delete your service, but if something like that happens, then operators will ensure that whatever was defined stays. They constantly monitor. So continuously monitors application resources, understands and responds to changes in real time. Helm Kustomize cannot do that. Automates lifecycle tasks like upgrade, backups, failovers, reconfigurations, and also scaling. Maintains system health by reconciling desired versus the current state. So the takeaway from this is, you could be deploying your operators using Helm, but Helm serves a different purpose, and that purpose is templatizing your application. But operators perform life cycle management. So when you combine both Helm and operators, then you get something extremely powerful. But understand that the function that Helm is doing cannot be performed by operators, and vice versa. Now let's see what is going on with this diagram. So what I have done is, this is the same thing that we discussed in the last lecture. We discussed that Shwetangi, for example, is a DevOps engineer, and Shwetangi created a CRD, and with the help of developers, Shwetangi also created a custom controller. Now what this custom controller was doing is, it was supposed to take backups, and the custom resource was created by Apurva. Apurva is a junior DevOps engineer. The custom resource that Apurva created is this one. I'll zoom out a little so that everything is on the screen, and I'll increase the font for this one so that you can see it. Please pardon me. Okay. Now what we are seeing here is, there is a custom resource created, and we are doing three things in this custom resource. There is a schedule, there is a retention days, and there is a target VPC, and all these things are associated with backup. And this is your operator. You have a controller, you have a CRD, and then you have created a custom resource out of that CRD. So here is an operator for you. But I want you to understand, there is a maturity level, and that is what we all aspire. So if you have an application, you will have various versions of application, and this is good, because you are taking the feedback, and based on that you are continuously updating your application. And that is what DevOps stands for. DevOps is continuously improving, and that is what applies to operators as well. There is a primitive operator, and then there is an advanced operator. So for example, we talked about our backup operator here. We created this, and then there was a custom controller that was ensuring that the backups were scheduled on this time, the retention was adhered to, and this was the target PVC for which the backup is to be taken. But understand, when I talk about a production grade backup operator, then it should also be doing these things: migrating legacy backups, triggering restores safely, compatibility validation before restores. It should also be performing reliability and resilience checks, for example, retry failed jobs with backoff, cleaning orphaned resources, handling concurrency and race conditions, observability. All things should be monitored, should be integrated with Prometheus, and there are so many things. This setup can also be categorized under a backup operator. Having said that, there are operators that are primitive, and then there are operators that are advanced. So if you are creating your custom operator, it could take time for it to reach a state that everyone in your team desires. So understand that this is, anything that has a custom controller can still be called an operator, but the difference is in the maturity level. Now that we have this understanding, I want to show you how can you create operator. So I'll go to browser and then I will go to the GitHub notes for this course. I'll go to day 40, and here I have given the methodologies that you can adhere to for creating a custom operator or for creating an operator in general. So I will go here. How can we create Kubernetes operators? Now you can create operators using Ansible, Helm as well. But if you want to have strong business logic, then nothing can beat a programming language. Hence, you would be using Go. Go is extremely powerful, and most of the Kubernetes default controllers like the deployment controller or the stateful set controller, all of these controllers are also written in Go. So if you want to create your Go operator, you can use operator SDK for Go and create them. And here I have also written how do you choose what to use. So if you are comfortable with Helm or Ansible, then you would use their respective operators. Similarly, if you are someone who has understanding of Go, Helm and Ansible, all three, then you would pretty much always be using Go, because with Go your operators can be more powerful. Now I want to move to the demo section, and today we are going to demo something that will give you two things, and you can introduce this into your production implementation as well. So this will be doing two things. We'll be deploying Kube-Green Operator. As the name implies, green, so it has something to do with sustainability with our environment. What will this operator do is it will bring down the number of replicas in a deployment stateful set or a cron job or anything that deploys or uses pods under the hood to 0 during the hours that you specify. And I could think of any of the development, UAT, QA, all these workloads which are not supposed to be running 24/7 could benefit from an operator like Kube-Green. So like I said, it will do two things for you. First, which every organization loves, that is cost optimization, FinOps. So this will help you reduce your costs, because understand, if the number of pods decrease, the number of underlying nodes will also decrease, hence you will save costs. Second, it is good for the environment because it reduces your CO2 footprint. And if you go to Kube-Green's website, they have also written some of the figures that will tell you how much footprint can be reduced if you use Kube-Green Operator. And here is the Kube-Green Operator. If I click onto this, I can go to this. This is the website of Kube-Green, and they can also show you how much of a reduction Kube-Green has caused for your specific implementation of Kubernetes. So let's deploy this operator. If I click on install, it is operatorhub.io. I search for Kube-Green. Now if I click on install, it will give me all the install instructions, or my GitHub repository has all the instructions that you would want to deploy this. So let's copy this first one and I'll go to my terminal. Now first what we are doing is we are installing something called OLM. What is OLM? So like you have Homebrew in Mac to manage packages, you similarly have OLM, Operator Lifecycle Manager, to manage operators. So in the first step, we have installed OLM. And now if I go back to the terminal, you will see that when I'm installing OLM, it is also installing some custom resource definitions. It is also creating a namespace. It is also creating another namespace. Then it is creating network policies, cluster role bindings. So we are deploying OLM also as kind of an operator. Because what is an operator? An operator will create CRDs for you, and out of those CRDs we'll be creating custom resources, or there could be certain custom resources that are created by default by the operator. But typically when you have CRDs, it is you who will be typically creating CRs that are leveraging those CRDs. And then there would also be a controller, and I'll show you that controller is usually implemented as a deployment, and we'll see that. And then there is finally use of built-in resources, and here we can see that cluster role, service account, cluster role bindings, all these are Kubernetes default resources. Network policies, these are also default resources. Now let's wait for this to complete. It took good 10-15 minutes, and finally the OLM is deployed. So if I run kubectl get deploy, I add -a to get the deployments of all the namespaces. You see that there was an OLM namespace created, and there are 3 deployments in that namespace. And if I run kubectl get ns namespace, you will see that there is an operators namespace created. You could create your operators in this namespace, and then there is OLM in which all these 3 deployments are there. So anything related to OLM is installed in the OLM namespace. And if I write kubectl get CRD, then you will see that there are close to 4, 5, 6, 7, 8 CRDs that are created by OLM operator, so to speak. This is fine. Now let's move to the meatier part, which is to install the Kube-Green operators. Once the OLM is installed, we can go and proceed to install Kube-Green operator. So I'll copy this, I'll paste this here, and this will install kubegreen.yaml. And if you want, you can go to this website and see what are the contents of this YAML. You can either do this, or I have already copied this. I'll commit this into the GitHub repository as well. So this is the content of this YAML. Now what we are doing is we are just installing Kube-Green, and we are saying we are doing this. Then, and the namespace that must be referred for this is OLM. A simple installation. Once I go to my terminal, you see that it has created this operator. Now if I click kubectl get CRDs again, then you will see that there is now a new CRD named sleep infos, and we know this is plural. And if I run kubectl API resources and I grep for, let's say, sleep, then you would see that there is a custom resource which can be created using this API version and this kind, and that is what we are going to do next. So if I go back here, so let's do one more thing. You see that there is a CRD called this. So let's see the contents of this CRD. So what this will tell us is what should be the schema, what should be the format of the custom resource that we create that will be using this CRD under the hood. So if I run kubectl get CRD and then I check for this one -o YAML, and I'll redirect this to, let's say, test.yaml. Then if I go to my Visual Studio Code, I zoom in a little, and then if I go to test.yaml, this is similar to the CRD that we saw in day 39 of this course. Here we are defining what will be the schema for this CRD, and any resource, custom resource that is created using this CRD will follow this. So let's now create a custom resource using this CRD. So the custom resource that I want to create is this one. Yeah. First, let's deploy a deployment. So what we will be doing is this Nginx deployment has 2 replicas right now. What we want this Kube-Green to do is I want this operator to bring this to 0 whenever there is non-business hours, and we will define non-business hours in our custom resource. So first, let me apply this YAML. I already have this in 01 app. So I'll go to my terminal. I will run kubectl apply -f02 and I'll apply this YAML. Once this YAML is applied, I should have applied 01.yaml. So let me first apply 01.yaml, kubectl delete F02, and then I will apply the 01 manifest that is for the application. So now if I run kubectl get deploy, I am running this in the default namespace itself. Here is my nginx deployment, and right now if I run kubectl get pods, I see that the pods are in container creating stage. That is fine. So now let's see what we want to do next. Next is we want to create a custom resource. Now let's see what we are doing with the custom resource in Visual Studio Code. So this is the YAML for that. What I'm saying is API version is Kube-Green, and we understand why it is Kube-Green. If we ran kubectl API resources in here and we saw API version is this, and that is the API version that we are using. Then the kind is sleep info, as we see here in the API resources section. And then what we are saying is the labels is app Kube-Green, name is sleep info sample. This is understood. Here what we are saying is I want you to exclude a deployment which is named critical app. So maybe this is running in your production and you want this to run 24/7. So you also have an option to exclude something, and I will let you read the operators documentation to see what all options are available at your disposal. I'm saying you must sleep at 2000 hours, that is 8 p.m. and then I want you to suspend cron jobs as well. Then there is time zone. Time zone is Asia, Kolkata. I'm in India, that's why I've chosen this time zone. Then I'm saying wake up at 8 a.m. and I'm saying do this every day, so all 7 days of the week. Now what I will do is I'll also apply this. First let me see whether the pods are created. Pods are created. I'll run kubectl apply -f02 and then I will apply this. This is created, but let me do one thing. It is saying sleep at 2000 hours. Let me modify this. I have 10:21 in my clock. Let me write this to 10:26. Sleep at 10:26. I'll save this. I'll reapply this. So essentially after 5 minutes, it will scale down my replica. So I'll run kubectl get pods -w. So essentially this, we should not see any pods running here. I'll also run the same for my deployment manifest. Kubectl get deploy -w. So right now it's saying that the deployment has 2 available and 2 is what we want. So essentially at 10:26 this should scale down to 0. So I'll pause the recording and I'll see you in 5 minutes. And I have 10:26 on my clock and you see that the replicas are now 0. Hence our operator is working as expected. So our controller in the operator is looking at my nginx deployment. And why it is looking at my nginx deployment? Because here I have told it to only exclude this deployment, rest cover all the deployments. Hence it took action and reduced the number of replicas. Very important. You can use this in your production implementations as well. And then we can come here. We see that there are no replicas running. You see it is completed. If I run kubectl get pods, I don't see any pods in the default namespace. And if I run kubectl get deploy, you see that there is an nginx deployment which has 0 replicas. If I run a describe kubectl describe deployment nginx, then you would see that scaled down replica set to 0 from 2. And that is what was done by our operator. If I run kubectl get pods -a, you can see that here is our Kube-Green controller which is running in the operators namespace. Like I told before, whenever you want to change the state of something, anything that could drift from a state or any backup policy, like we said, static configuration will not do anything. If you want to take action, you want to have a controller. And here in the operators namespace, sleep info has deployed the Kube-Green controller which is taking action based on whatever we have defined in CR custom resource, and we know we define our intent in the custom resource. That concludes this lecture. You now know how operators turn Kubernetes from a declarative scheduler into a self-managing platform. In day 41, we'll look at pod security, because with great power comes great responsibility. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.